Okay, now is the part 3, the last 10 questions. Okay, so question 21, which of the following shows no work is being done? Now, work is having this formula, work done is equal to force times distance. So over here, if you drag a load across a distance, so there is a force being moved, all right, so there's work done. Likewise, if you kick a ball, all right, so there's force applied and the ball is moving, so there's force times distance. When you lean against a concrete wall, I think it's very clear that there's no movement. So when there's no movement means no distance move. So answer will be no work is done. All right, so answer will be C. But if you look at D as well, just to double check, throwing an object up in the air. So when you throw the object up in the air, there's movement, there's force applied, so there's work done. So answer is C. Question 22, which one will best describe the difference between biomass and fossil fuels? Alright, this one is a very factual question. So the answer will be biomass are renewable. Okay, you see renewable, but fossil fuels are not. Alright, so the other options, right, like biomass generate more energy than fossil fuel, this is not true. But biomass fuels generate more pollution than fossil fuel. It depends. So it's not this is a sweeping statement. That means it's not true all the time. Biomass originate from both plants and animals, but fossil fuels originate from plant only. I don't think it's fossil fuels from plant only. Sometimes even it can originate from animals as well. So this statement is also wrong. So answer is A. Now, question 23, a pupil swings on a rope tied to a branch of a tree. At which mark is the pupil's kinetic energy the greatest? So, over here, at the lowest point, this will be the fastest. Alright, so this is something that is very straightforward. At the lowest point, your PE is least, so your KE will be the most. So, according to conservation of energy, at the lowest point, you will have the fastest speed. Alright, so answer is B. Question 24. A ball is dropped from height as shown, ignoring the effects of air resistance. So the total energy. Now, when we talk about total energy, what can we say about it? Well, obviously, we learned about conservation of energy. It will be the same at all points. Okay? Now, question 25. Here you have this hair dryer, all right, and they ask what's the value of energy Z. Well, we know this is a total, so if you just subtract this one, all right, you got 499 joules. Now 499, you subtract 498.8, you get 0.2. All right, so the answer will be A. And what type of energy could Y be? Now this is a hair dryer, so we know that Y uses the most energy. So I will presume that this is heat. All right. So for Z, 0.2 joules, very little. Maybe that is light energy, and this could be sound. Okay. So we don't really know, but for sure, heat must use the there must be most of the energy being converted into heat energy, because that's what the hair dryer is for, right? Okay. So answer for 26, thermal energy. Okay, 27. Now the table shows the speed of sound varies with substances of different densities at room temperature. So based on the info, what can we conclude about the speed of sound? So if you look very carefully, it appears that as the density increases, your speed of sound will change. But is there a fixed pattern to it? Well, here part A, they say speed of sound is greater in less dense mediums. So if I look at the least dense 1.29, right, which is air, speed of sound is 330. But when the density increased to 1.43, the speed actually decreased. Okay, so this is true for the first two. All right, but if you go to this 2710, right, aluminium, the speed apparently increased. So we cannot say that it is always greater in less dense. Okay, so I just have to find one example. I can debunk this option A. For B, the speed of sound is greater in metals than in gases. So let me highlight gases. Alright, so these are gases, and matter will be these three. So it's very clear that they are the speed of sound is greater in matters than in gases. So this is correct. So B is correct. And part C, speed of sound is greatest in the densest matter. Obviously this is not true, because in the densest matter is 11300 here for the lead, but it's not the fastest. Alright, the speed of sound is faster in aluminium than in lead. Part D, the speed of sound increases as the density of the medium increases. This is also not true. When this increases, we see that there's a drop in lead. Alright, in fact, from aluminium to iron, there's also a drop. So this is not true. Okay, so answer is B. Okay, question 28. Now, a girl hears an echo when she claps her hand near a high wall. What happens to the echo if she moves nearer to the wall? Now, if you are going closer to the wall, obviously it will be louder, alright? And it will take less time to reach you, okay? The reason because when the echo hits the wall, it needs some time to reach you back, okay? You need some time. So the closer you are, the less distance is required for the sound to move in order to reach you. So it will take less time to reach you, okay? How about the pitch? Now pitch is this pitch, right, depends on frequency. Depends on frequency of how you clap. Okay, so this doesn't really change. Okay, so for part A and B, they are out. Part C is louder, but it takes longer. So longer means wrong already. It should be less time. Okay, question 29. Now the information shows the process of decomposition taking place in the test tube upon strong heating. So you can see that X now becomes Y plus Z. So which one is not correct? So over here, they say both Y and Z could be compounds. This one we not sure, okay, but maybe. Alright, X could be an element. If this is an element, then you will not be able to break it down with any processor. You heat it up, right? It shouldn't break down into simpler substances of Y plus Z. So this is definitely wrong. Okay, but we ask which one is not correct, right? Then this is what we want already. Okay, so answer is B. Okay, for C, Y could be an element. Well, it's possible. Z could be an element. It's possible, but we are not trying to find out whether it's true or not. So, but what is wrong, right, is X could be an element. This is definitely wrong. Okay, last question here. The reaction of steam on iron is represented by the chemical reaction. So what are the values of X and Y? Now, if you look at this X, right, is for the iron, and here it says iron 2. So I can know for sure this one is 2 already, because there's no other iron in this this term here. Okay, and then for Y, right, it's asking for H2. Alright, so if you do the math, alright, there's 3 oxygen over here. This one, 3 oxygen. So the oxygen must come from here, right? That means this Y must be 3. Alright, so the answer will be B. Okay, so students, that's the end of this walkthrough for the second set of paper. So please do a correction, and if you got any question, please ask in the Google Classroom. Alright, thank you.